This is Trig Identities, part number 18. And tonight I'm going to show you what I promised to show you a long time ago. And that is how to find the sum of the sine of a plus b. Okay? Now here's how this works. We have a unit circle here. This is the radius of a unit circle. Now what is the radius of a unit circle? It's one of something. It doesn't matter whether it's millimeters, centimeters, miles, kilometers. It doesn't matter. As long as it's one of something, you're okay. Alright? Now, we have more than one radius of this circle. Now, what's the plural of radius? Radii. So now we have 3 radii. That's what we have. Alright. And those 3 radii form 2 angles. Angle A, angle B. Now, if we wanted to find the sine of angle A, that would be easy. But even using Euclid, we would have a tough time finding the sine of angle B. Not to mention the fact that you have to add those 2 together to get the sine of A plus B. Now you got a real problem on your hands. What are you going to do about this? Okay, what you're going to do first of all is draw a chord. What is a chord? Well, it looks an awful lot like a secant line. Because what you're doing is you're connecting 2 points on the circumference of a circle. That's what you're doing here. The difference between a secant line and a chord is that a secant line runs outside the circle as well as inside. The chord stays inside the circle. Now, what else can we do? Well, what we can do is duplicate angle B. How do we do that? Euclid Book 1. Euclid Book 1 teaches us how to duplicate angles. And that's precisely what we're going to do. So now we have a duplicate of angle B. Then we can draw another chord from this point right here to this one right down here. And this is what we did at the beginning of my Trig Identity video series to prove the cosine of A plus B. We used the distance formula to do it. And we could do the same thing here, except it's not really necessary. And I'll show you why. Okay? Alright. Now let's review a couple of trig identities, which are really important. We've already established through Euclid, through Claudius Ptolemy, through Descartes, and finally Fermat and Newton, that the sine of negative A equals the negative sine of A. We can also firmly establish that the cosine of negative A equals the cosine of A. We already established this. Okay. Now, what about I keep doing this. Instead of writing down 90 degrees, I keep writing down 90 squared, and that's not right. See that? We can do that. Now then, what else can we do? We can do this too. Why can we do these last 2 right here? Well, let's take a look at a right triangle. which is some of the biggest foundation of trig. Okay? We know that a triangle contains 180 degrees. We already know that this angle is 90 degrees because it's a right angle. So now, if you add x, 90 degrees minus x, and 90 degrees together, you get 180 degrees. That's a fact. So, adding these three angles together, you get 180 degrees, and that's why we can say that these two angles added together are going to be 90, because 90 plus 90 is 180 degrees. So now we got x and 90 degrees minus x. And that's how we can do both of these. If you have any questions about that, leave them down here in the comments below and I'll tell you more. But that's how that works. Okay. Now, the final thing we have to remember before I go into Trig Identities Part 19 and go on with this, and I hope you'll write all of this down. I need you to write all this down. Okay? Take a picture of it if you have to. But write this down, take a picture of it, have it on hand, because in my next video, this isn't going to be there. Okay? Now, the final thing I'm going to show you is what we learned a few videos ago. You remember how we found the cosine of a minus b, and we had all this as the equation? Okay? I want you to keep that in mind because we're going to be using that. Not immediately, but we are going to be using that. And I'll show you how to do that in my next video. And when we use this, we're going to use this to find this. So hold on to your hats, folks, because this is going to be a doozy. I'll tell you more in my next video. Stay tuned.